Hello, Mr. Shu here again. Let's talk about the square root math algorithm, part 2, example 2. So this is something you can use to find the exact digits in a radical or a square root. And I talked about that in detail in part 1. And if you're on TikTok, you can um, click on my name and look at my different postings and find part 1. And if you are watching on YouTube, there will be a link on the last screen. So example 2, we're trying to find the exact digits in the square root of 30 without using a calculator. And remember that radical sign or square root sign, it's like a division sign, like in long division, from when you were in elementary, if you were ever taught that. There's a little bit of a difference because you put a decimal after the number and then you put two zeros together and then you're going to pull them down as a group. And like I said, I talked about that in detail. And so we're going to write the largest perfect square up above the 30 that can be subtracted from 30. And remember, you just square the number. The largest one that we can subtract from 30. 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36. So we have to do the 5 squared. I'm going to move this down just a little bit because it is too high. All right, so I'm going to write the 5 that I'm going to square right up above the 30. And we have to make the decimal just like you would do if you were dividing. And 5 squared is 25. So I write the 25 down here. And then I'm going to subtract this just like you would in a regular subtraction problem. And then I'm going to bring the double zeros down after I subtract the 25 from the 5. So 20 from the 30. Bring my double zero down. And that's how it's a little bit different. So you just have to follow all of these particular steps. Now, here's the hardest step for people to remember. And it's very hard when you're proving why this algorithm works that you wouldn't do until you got into a college level class. So I'm going to double the 5. And 5 doubled is 10. And I'm just going to write it down here at the bottom because it's just someplace that I'm going to have to work. And the number I'm dealing with is a 3-digit number. So the 10 came from doubling that 5. So it's 10 and then a 1. So it's 100 and something. And so I have to ask how many times will 100 and something divide into and be able to be subtracted from 500. So what does that mean? Whatever number I put in up above here, I also have to put on this ones and use it in the multiplication problem. That's where this is different. So if we didn't have to do that, we would know it would be 5. But since we have to put the number down there in the ones before we multiply, we have to put a 4 here. So now we take, and now we're going to multiply by 4. This is similar to what you would be doing in a regular division problem. 4 times the 4 is 16. Carry the 1. 4 times 0 is 0 plus 1 is 1. And the 4 times 1 is 4. So the answer is 416. So I'm going to subtract 416 here. The only time that you squared anything was on the first digit. I subtract here and I get an 84. And remember, we're repeating the process now. So if I repeat that process, I am going to double the number above the radical sign. I'm going to move this up just a little bit so that we can see this just fine. So I'm going to double the 54. 54 doubled is 108. And remember, you have this ones digit here, and we bring the double zero down. So if I put an 8 in here, it's going to be 8,000, and I'm going to carry a 6, so it'd be 8,600, which would be too big. So I have to put a 7 in here. And I have to put the 7 in here. And then I multiply this by 7. 7 times 7 is 49. Carry my 4. 7 times 8 is 56 plus 4 is 60. Carry my 6. 7 times 0 is 0 plus 6 is 6. 7 times 1 is 7. So I subtract 7,609. 9 from the 0 I borrow, so that's going to be a 1. This is a 9 here. And we've got an 8 here. We continue this process, but it's going to be 5.47 something. And usually you're going to round the nearest tenth or the nearest hundredth. So we can keep going, but the numbers start getting big. Then we can take a calculator and check it for accuracy on the calculator, and it's 5.47722. So this is the way that it had to be done when I was your age doing problems, because I did not have calculators at my access to use. And so this is the way we did it. And when I was in college doing my teacher training, I was talking to professors, and they didn't even know about this. So I had to explain it to them. And it was interesting watching them absorb the information from one of their students, and it's something they didn't know. And some of these professors were geniuses too. So example 1, we worked in part 1 video. So follow me on TikTok, and then you can access my other videos. Subscribe to me on YouTube, and then you'll see more math videos. Toward the end of this video, there will be a link that comes onto the screen so that you can click on it to see the other link to the part 1 if you're watching on YouTube. I do appreciate you watching. Please get your friends to subscribe to my channel so that I can share more interesting math videos with you. See you next time, Mr. Chew out.